Okay, we've just seen a difference of two squares, which is one of the special forms that we can factor. Now I want us to remember the other two special products, and I want to look at those as special forms that can be factored as well. So we're going to recall two more special products that we saw before. The first one was f plus L times f plus L. And we saw that that was f squared plus 2fl plus L squared. Remember, this one had an extra term. It was twice the product of the first and the last terms. If we rearrange this and switch the left and right hand sides, now we have a factoring method. F squared plus 2fl plus L squared equals f plus L times f plus L. Similarly, we had one more special product, f minus L times f minus L equals f squared minus 2fl plus L squared. If we switch the two sides of that equation, we get a special form that we can factor, f squared minus 2fl plus L squared can be factored as f minus L times f minus L. These are the two special forms that we are going to be factoring now. Let's look at some examples so you can see how this works. Let's factor x squared plus 14x plus 49. Now, this one looks a little bit more like the first one than the second, because the second one has that negative middle term, and the first one is a positive middle term. So let's see if this fits the bill. We need the first and the last ones to be perfect squares. Well, x squared is x squared, and 49 is 7 squared. So those are both perfect squares. But we also need this middle bit to be double the product. Well, the product of x and 7 is 7x, and if you double that, you get 14x. Because this fits with all of these different requirements, we know that this is the special form, and we can write it as f plus L. In this case, it's going to be x plus 7 times itself, x plus 7. And this is the factored form. Let's take a look at another one. Let's look at x squared minus 18x plus 81. This one looks a little bit more like the second form because we've got that negative term in the middle. So let's check and see if it fits. We need the first term and the last to be perfect squares. Well, x squared is x squared, and 81 is 9 squared, so that works. But we also need this middle term to be double the product. Well, the product of x and 9 is 9x, and if we double that, we get 18x, so this works, and we can use the formula. This says that we get f minus L times f minus L. In this case, that's going to give us x minus 9 times x minus 9, which is our final answer. We can also write this as x minus 9 squared. Either one of these would be acceptable. You don't have to do both of them. I just want to show you both of them so you can see that both of them are acceptable. How could we rewrite this first one? Instead of x plus 7 times x plus 7, x plus 7 squared. Also acceptable. All right. Now, you might be thinking to yourself, why do I need to use these methods if I could have just used the unfoiling method for each of these? And there's a couple of reasons why we don't just want to rely on unfoiling. First, we're going to see things like this later on in the semester, and you will see them in future math classes, and being able to recognize these special forms is going to end up being really important. Also, though, This method works on much more complicated problems. Let's do one more. 16x squared plus 40xy plus 25y squared. This is quite complicated compared to the ones we've seen before. Not only is there a leading coefficient, but we have multiple variables in this problem. So it would be very challenging to use other methods, but if we recognize this as a special form, it's not that bad. This actually fits the first special form here. Let's go through and verify that. The first term is a perfect square. It's 4x squared. The last term is a perfect square. It's 5y squared. If we take the product of 4x and 5y, we get 20xy. And if we double it, that gives us 40xy. So because all of this fits, we know that we can use that formula. And so this becomes 4x plus 5y times 4x plus 5y. Recognizing that this is a special form allows us to factor it quite easily. And we do have a name for these special forms. These are called perfect square trinomials. The reason we call them that is because they are trinomials. Each one of these is a trinomial. And when we factor it, we can factor it as a perfect square, some quantity squared. Please go through the example problems in the linked videos below to get more comfortable with recognizing these perfect square trinomials and applying the formulas to factor them.